In this tutorial, we are going to talk about simple harmonic motion practice questions. So I've got a number of questions with me here. The first question is saying, find the amplitude, frequency, and period of motion for an object vibrating at the end of the horizontal spring if the equation for its position as a function of time is x is equal to 0.250 cos pi over 5t. Then we have got in close the brackets. Part B, find the maximum magnitude of the velocity and acceleration. Okay. Part C, what are the position, velocity and acceleration of the object after 1 second has elapsed? Okay, now we have been told that we need to find the amplitude, the frequency and the period. Given that the x is equal to 0.250, then we have cos. Inside there we have a pi over 5 times t. Okay, now the formula for the position as a function of x is given by x is equal to the amplitude times cos omega times t. Then the formula for velocity as a function of time is given by the velocity is equal to negative omega times amplitude. Then you have sine wt. Then the acceleration is given by negative omega squared times a cos omega times t. Now, as we can see from our formula here, we know that this formula which we have been given, that x is equal to 0.25 cos pi over 5 times t, this is the formula for what? The position as a function of time. Okay, now the first part here is the amplitude. This part here is the angular frequency. So under simple harmonic motion, whenever you see omega, that is the angular frequency. Okay, and it is measured in rad per second. Okay, now so from here we can see that they're asking us to find the period, so the amplitude. So from here we can see that the amplitude is just basically 0.250 meters. Okay, what of the frequency? We know that uh, the angular frequency is given by 2 pi f. Now you can know where this formula is coming from, because we derived this formula already in the previous video. So you can just watch the previous video which I just uploaded, then you'll be able to know where this formula is coming from. Okay, so now this is the formula for angular frequency. So now our goal is to find the what? We have the angular frequency, but we want to find, this is the formula. We want to find the frequency. So we're going to divide both sides by the 2 pi. So we're going to have the frequency is going to be this divided by 2 pi. So let's plug in the values. So we're going to see that our frequency is going to be equal to, the angular frequency is this part here. So we have this part, pi over 5. So we have pi over 5, everything divided by 2 pi. Okay, so if we get our calculator, we say pi divided by 5, I'm getting 0.628. Then I divide this one by 2 pi, I'm getting 0.1, meaning that my frequency is just basically 0.1. Okay, so that is my frequency. Now, what we need to understand here again is that we have been asked to find the period as well. So we know that the frequency is also given by 1 over period, meaning that period is equal to 1 over frequency. So we can just get the 1 divided by frequency, which is 0.1. So we're going to have 1 divided by 0.1, which is going to give us 10. So our period is just basically 10 seconds. Okay, so we are done with part A. Let's go to part B. Part B is asking us to find the maximum acceleration. Now, here, if we are finding the maximum acceleration, let's start with the velocity. Okay, so when an object is moving, Okay, we know that under circular motion, how do we find the linear velocity? So the linear velocity is given by v is equal to omega times r. Now when it comes, this is the radius. Now when it comes for circular motion, we know that this radius from here all the way to there, that is our radius. Now if we come to simple harmonic motion, this radius is what we call the amplitude. So where there is r, I'm going to put the amplitude. Okay, so now I'm going to continue here and say where there is r, I'm going to put what? I'm going to put uh, the amplitude. Okay, I'm going to put the what? The amplitude. I'm going to say this times this. Okay, so meaning that my Vmax is going to be equal to omega times A. Sometimes if you don't want to use this one, you can also use this formula. We know quite okay that if we are to derive the formula for the velocity, okay, the maximum velocity, we are coming from the conservation of energy. Okay, now the conservation of energy, we are going to find that I want us to come up with this formula, which is going to be A times this. Sorry, I'm talking about V is equal to this times this. Okay, so I want us to come up with that formula. Now we know that mechanical energy is equal to the kinetic energy plus the elastic potential energy. So when we talk about the maximum, when we talk about the maximum velocity, is at equilibrium where x is equal to 0. So meaning the potential energy, because potential energy is given by half kx squared. So where the x is 0, meaning this part is going to be 0. Okay, so now meaning that this part is going to be 0, so we're going to have this, and mechanical energy is given by half ka squared. Okay, and then this is going to be equal to we have this mv squared. Okay, so we can cancel the half, and then we are going to have k a squared is going to be equal to mv squared. So we want to find the velocity, that is the maximum velocity. We divide both sides by m, even here by m. So we are going to see that um, our v, we are going to have v squared is going to be equal to k a squared over m. So we get the square root to both sides. We are going to have v is going to be equal to the root of k over m. So this is squared, I can just put it outside. Okay, now if this is our velocity, what I want us to understand is that angular frequency is also given by the square root of k over m. So since we don't have this constant here, so we can't use this, so we are going to replace where there is this with angular frequency. So that's why we can say that v is equal to wa. So that is the formula where it is coming from if you want another way around. Okay, so now from there we can plug in the values. We see what the answer which we are going to get. So the formula which is going to give us the maximum velocity is going to be this time this. So we're going to get this guy is just basically pi over 5 times the amplitude is 0.25. Okay, so we're going to get the maximum velocity as pi over 5 times 0.25. So I'm getting my maximum as 0.157. So it is meters per second. Okay, that is my maximum velocity. Now let's talk about maximum acceleration. So maximum acceleration, when you have been given this guy here, you just square the omega. So we're going to have this. We're going to have the maximum acceleration. It's going to give us omega squared times m. So it's going to be pi over 5, we square it, times 0.5. Okay, so we have pi over 5, and then we square it. I get the answer, then I square it, and then times 0.25. So I'm getting my acceleration as 0.0, I can just say 0.1 meters per second square. That is my maximum acceleration. Okay, let's go to part C. So part C is asking us what are the position, velocity and acceleration of the object after 1 second. Now, we want to find the position. Remember I said these are the three formulas which they're going to give us the what? As a function of time. The position, the velocity. When they talk about the position, they're talking about the displacement. So we've got the displacement, we have got the velocity, we have got the what? The acceleration. So let's start with the first part. The position is going to be given by this. Then you have this. So time we have been given that is supposed to be 1 second. So we're going to say that x is going to be equal to the amplitude is 0.25, and then we have cos. This guy inside there is pi over 5, and then the time is just basically 1. Okay, so we have 0.25, and then cos open brackets, we have pi over 5 times 1 inside there, pi over 1, and then um, it's pi over 5, sorry, pi over 5, then times 1. Okay, so I'm getting my position as 0.202 meters. Okay, let's find the velocity. So the velocity is given by the formula which is going to be v, which is going to be v is equal to negative alpha times a sine, then here we have this. So we can plug in the values. This guy is just basically pi over 5 times 0.25, which is the angular, or the amplitude, sorry. Then we also have this over 5 times 1. Okay, so if we are to get the calculator and find the value of the velocity, we are going to find that we're going to have pi divided by 5 times 0.25. So the answer I'm getting, I get it, then I say times what? Times sine, and then inside there we have pi over 5 times 1. So I'm getting my velocity as 0.092 meters per second. Okay, then let's go to acceleration. That is our velocity. Let's go to acceleration. So our acceleration now, we're going to have acceleration is equal to negative alpha angular frequency squared a, then you have cos this. So let's plug in the values. We have got pi over 5, now we square it, times 0.25 cos pi over 5 times 1. Okay, so we have we have pi divided by 5 times 0. I have to square it. So I say, let me do it. I'm saying pi divided by 5, I need to square it, then times 0.25, 0.25, and then I have cos. I do open the brackets, then I say pi again divided by 5 times 1, then close the brackets. Okay, so the answer I'm getting is basically negative what? Negative. Oh, that one, the velocity was supposed to be negative. You put negative because there's negative here. So it's going to be negative 0.0798 meters per second squared. So that is our acceleration. Okay, so that is it about this question. So we have got the next question. We have got the next question, which is saying a block of mass 50.6 kgs attached to a spring with force constant of 130 newton per meter is free to move on a frictionless horizontal surface as shown in the figure below. The block released from rest after the spring is stretched a distance of A is equal to 50.13 meters. At that instant, find the force of the block, but B, find its acceleration. Okay, so now we know that this is just direct Hooke's law. We know that we have got the resultant force is equal to negative kx. Okay, so we want to find the force. We have been given, we know that it has reached at its maximum position. So when you reach at the maximum position, x is equal to plus or minus a. So in this case, we are going to get our x as 50.13 meters. Okay, so we're going to say that we are going to have the spring constant is what? Is 130. So we are going to ignore the negative because we want to get the magnitude of what? The force. Okay, so we have Newton per meter times the x value is 50.13 meters. So the meter and meter will cancel. As you can see, this and this will cancel. So we're going to have 130 times 50.13. Okay, so I have got 6,516.9. So my resultant force is going to be equal to 6,516.9 Newton. So that is part A. Then part B is asking us to find the maximum acceleration. So we find the acceleration. Now, if we want to find the acceleration, what we are going to do is we know that we have the resultant force is equal to negative k. Then we have what? We have x. Okay, but at the same time, we know that the force is given by mass times acceleration. So meaning this time we are trying to find the maximum acceleration. So I'm going to replace this one where there is force. So I'm going to say that this is going to be this. It's going to be equal to. So let's just ignore the negative. It's okay. Don't mind about the negative. And then we want to find the value of A. Okay. So we're going to divide M, and then A is going to be equal to K x over M. Okay. Then now from there, what we need to understand is that when you reach at the maximum position, x is equal to A. So I'm going to replace x with A. So the maximum, when I talk of the maximum, meaning we have reached at the maximum position, not so. Okay. So now what you're going to have there is going to be the acceleration. The maximum acceleration is going to be equal to k A over M. So in some books, you are going to find that this formula they are going to put it like this: A max is given by k over M times M. Why they are putting this? Because they know that these two are constant, so they isolate this one can change anytime. Okay, so let's plug in the values. We see what we are going to have. So we have A is equal to, we have the K, which is 130, then over, we have the mass, which is 50.60, then everything times the amplitude, which is 50.13. So we are going to say that 130 times 50.13. Okay, and then what else do we have? We have then I do divide this one by 50.60, which is giving me 128. Okay, so our acceleration in this case is going to be equal to 128.8 meters per second squared, So that is it about this question. Now let's go to the next one. We have got the question here which is saying we have got a block of mass 52 kgs is attached to a spring of force constant 55.003 times 10. This is supposed to be times 10 raised to the power 2. So the k is just basically 55.003 times 10 raised to the power 2 Newton per meter. That lies on a horizontal frictionless surface as shown in the figure below. Although there is no any diagram here, it's okay. So the block is put to a position of x is equal to 55 centimeters to the right. So let's say we have got let's have the spring. Okay, so they're saying that this is the equilibrium position, so it has been put at x is equal to, so this value of x from here all the way to this point here is just basically 55 centimeters. Okay, and then the mass of this block is just basically 52, and then the k value we have been given. Now the first question is asking us to say uh, find the work required to stretch the spring. Okay, so we're trying to find the work. So work is always given by half kx squared. Now, the formula for work is the same as the formula for elastic potential energy, but you can check out the previous video which I uploaded on how to come up with these formulas. Okay, so this is the formula for finding work and the elastic potential energy. They are the same. So it's half k x squared. So we want to find the same work. So we're going to use the same formula. So we have got we have a half, and then we have the k value we have been given, that is 55.003 times 10 raised to the power 2 times the x value. It is 55 centimeters, so we are supposed to convert that one, which is going to give us 0.55. Now we square it. Okay, so we're going to have 1 over 2 is 0.5 times we are going to have times 55.003, then exponent 2, then times 0.55. I square it. Okay, so I'm getting my work done as the 831.92 joules. So that is it for part A. Then part B is saying the speed of the block as it passes through the equilibrium. Now, when when an object is passing through the at equilibrium, just know that at that particular point we are talking about the maximum velocity. Okay, because from this formula, from this mechanical conservation of energy, we know that if we are passing at x is equal to 0, that is at equilibrium, we don't have elastic potential energy, so this part is going to be 0. Okay, so to come up with the formula, we're going to see that this one is given by this, then this is given by this. So you just make v as a subject of formula. Okay, so the half they will go, then you're going to have k a squared is equal to mv squared. We divide by m, we divide by m. We are going to see that our v squared is going to be equal to ka squared over m. So we can get the square root to both sides. We are going to see that when it was passing through the equilibrium, we're going to see that v is going to be equal to the square root of k, this is squared, k over m times a squared. So you can just put this formula as k over m times a. Then you remove the square. You can plug in the values directly there, or you can put it the way they are there. Okay, now from there we are going to say that the velocity is going to be equal to our k value. We have been told that it is 55.003 times 10 raised to the power 2. we divide this one by the mass, which is 52, then times the amplitude. The amplitude is at this case is going to be the same as the x. Okay, so we're going to have 0.55 in meters. So we're going to have 0.55. Okay, so now from here, what I want us to understand is that we're going to have um, we are going to have 55.003 exponent 2 is to the power 2. Then I divide this one by 52. I get the answer. I'm getting 105.775. Then I get the square root. Okay, so if I get the square root, the answer I'm going to get, I'm getting 10.28 times 0.55. Okay, so I'm getting my speed as 5.6656. So I can just say it's 5.6, or I can just round it off and then I say 5.66 meters per second. Okay, so that is our velocity. So we have v is going to be equal to 5.66 meters per second. That is our velocity as it was passing through the equilibrium. Okay, that is it for this question. Then you have got number 4. A simple pendulum has a length of 52.0 centimeters and makes 82 complete oscillation in 2 minutes. Find A, the period, and the period of the pendulum and the value of G at the location of the pendulum. Okay, now what we need to understand here is we are going to have a simple pendulum. So if this happens to be our simple pendulum, this is our simple pendulum, and then we are going to have this. We're going to have this. So it is swinging. So let's say this is point A, point B, point C. So now for this, from point A all the way to point C, that is half. Okay, then as it comes back to A, that is 1 cycle. Okay, so we mean that from A all the way to B and back to, from A to C all the way to A again, that is 1 cycle. So now the question is asking us to find the what? The period. Okay, so we know that the period is given by the number of times over the number of what? The cycle, or the number of oscillation is the same. Okay, so we can say the period is given by the time over the number of oscillation. So now we have been told that we have got period, which is t, is going to be equal to the time divided by the oscillation. So now we have the oscillation, which is 82. Then we have got 60 minutes. We have to convert this one into seconds. So we have just to do 2 times 60, which is going to be 120 seconds. Okay, so we're going to have period is going to be equal to, we have got the time. The time which have been given is just basically what? It is 2 minutes, so it's 120 seconds. So 120 seconds, everything divided by the number of cycle, which is 82. Okay, so we have 120 divided by 82. So I'm getting 1.463 seconds. So that is our period. Now we want to find the value of G. Now when you're talking about the simple pendulum, there is what we call there's another formula for period which we can use, okay, which is very, very important. We are supposed to know it. Okay, so another formula for simple pendulum is given by t is equal to 2 pi times the square root of L over G. So now our goal is to find the G. Now we talked about how to derive this formula, and it's very, very, very much important for you to know where this formula is coming from. Okay, so where is this formula coming from? So this formula is coming from here. If you have got a physical pendulum, and then this physical pendulum, it is swinging, okay, then the period is given by the 2 pi times the square root of the moment of inertia, everything divided by the mass times g times L. So we're talking about the mass of the physical material which you have, which is swinging, then the gravitational, because it is under the influence of gravity, then you've got the length. That material which is swinging is going to have the length. Okay, now the moment of inertia is given by ml squared. So we can replace this part with the where there is moment of inertia. So it's going to be, period is going to be equal to ml squared is going to be divided by this. So we can cancel the m, we can cancel the l here, we can remain with one l. So we still have 2 pi here, sorry. So we're going to have t is going to be equal to 2 pi the square root of um we have remained with one l, so l divided by g. That's where this formula is coming from. Okay, now if you want to find frequency, you know that frequency is going to be equal to, frequency is 1 over period. So you can just put the whole of this where there is a period, and then you're going to discover that the formula is going to be 1 over 2 pi, then everything divided times what, g over l. Okay, so it's very very important for you to know where this formula is coming from. Now let's solve this question. We are trying to come up with the g. So we are saying that period is equal to the value for period, the one we found, is going to help us. Very very important. We said it was period was equal to 1.4 was 463 seconds. Okay, now this is given by 2 pi times the square root of l over g. So we want to find the value of g. So we can square both sides. Okay, even here we square it. So we're going to say that t squared is going to be equal to, so it's going to be 2 squared. If we square this one, it's going to give us 4 pi squared, then l over g. So our goal is to find g. We can do cross multiply. So we can say that we are going to have here there's 1, I'm putting 1 there. So we can say that we're going to have t squared times g is equal to 4 pi squared over l. Let's divide both sides by period squared, period squared. So we're going to see that our g, okay, we're going to see that our g is going to be equal to, g is going to be equal to 4 pi squared l, everything divided by what? Divided by period squared. Now let's plug in the values. Okay, so we have our g, which is we have our 4, then pi squared. Our length, we have been told that length is 52 centimeters, so we have to convert that one, is going to be 0.52 meters. Okay, and then everything divided by what? By the period which we have found is 1.463. Now we square it. So we get our calculator and say we're going to have 4, then pi squared times 0.52, everything divided by 1.463, I square it. So I'm getting my g as 9.59 meters per second squared, or we can say g is equal to 9.6 meters per second squared. So that is it about this question. Okay, now let's go to the next question. So we have got another question which is saying the wheel in a simplified engine in figure below has a is equal to 0.50 meters, rotate with angular frequency of 12.12 rad per second. At t is equal to 0, x is equal to a. Okay, calculate the positions, the piston's position, a position, b velocity, c acceleration when t is equal to 1.5. Okay, now this is the same question, as in we are going to be using the same formulas, these formulas as a function of time. Okay, so we know that we have this for position. So we have been told that the a is just basically 0.25. uh, then we have sine. The angular frequency we have been told that is 12 times the time is 1.15. Now the calculator you are supposed to change it is supposed to be in radian. Okay, very very important guys. The calculator is supposed to be in rad. Okay, because this guy here it is in rad. So for us to find the correct answer, we are supposed to convert the calculator. Our calculator is supposed to be in rad. So we're going to say 0.25. And then we have sine. We have sine. We have sine. Then I put open brackets. We have 12 times 1.15. Okay. So now, if you have converted your calculator, we are supposed to find. You are supposed to find. It's supposed to be. I'm getting 0.8 here. So you can confirm with your calculator the answer which I'm getting after converting my calculator into a LAD. I'm getting 0.0827 meters. Okay, that is part A. Let's go to part B. So part B, we have the velocity. We know that the formula for finding the velocity is just basically a v as a function of t is given by negative this. We have this. These are the formulas. Now if you want to know more about how these formulas are coming about, you can just check out the video where I explained about on how to drive the equations on simple harmonic motion. Okay, so we have negative this we have been given, that is 12, and then we are going to have the a, which is 0.25, and then you have sine 12 times 1.15. So make sure your calculator is in rad, so you'll be able to get. Okay, so I have 12 times 0.25 sine, open brackets, 12 times 1.15. Okay, answer. So now I'm getting negative 2.83 meters per second. That is my velocity. What of the acceleration? Okay, so it's just a matter of us knowing these formulas. Okay, now it becomes very simple for you to know where they're coming from. Acceleration is equal to negative this squared, then we have cos, we have this. So let's plug in the values. So we have the 12 squared times 0.25, then you have cos, open brackets, we have 12 times the time, which is just basically 1.15. Okay, so let's see the answer which we're going to get. We're supposed to put negative here. So we have got 12 squared and then times 0.05 cos, open brackets, 12, and then times 1.15, close the brackets. Answer. So the answer I'm getting here is negative 11.9 meters per second squared. Okay, so that is it for this question. Thank you very much for watching this video.